Okay, so thank you very much for coming. We'll start this developer user roundtable 1. I'm sorry for the delay. It's just that the workshops have finished a bit late, and we so went late for lunch, and we're out late for by about half an hour. So I'm sorry for that, but we should be able to catch up, and we won't be too late at the end. So with this first section, we're going to be talking about kind of more technological aspects of it, and we have 4 speakers that will initiate discussions in the different areas. John will be talking about what our plans are for the multi-threading in conjunction with the new parser. Michael will talk a little bit about the ideas of new language features and whether they will be introduced in csound 5 or whether it should be taken later, and what things that we might be coming up to the horizon. And then some ideas about performance improvements, and Andrés there will also talk a little bit about that. And finally, Francois will be saying a few words about the csound API and how that's working and improvements for that as well. So, and all of us will kind of chip in whenever we feel that we have something to say in an orderly manner, I'd say. So, John, please, would you like to start talking about? I'm not going to be the interviewer here, so
okay.
Could you tell us a little bit about the plans for the new parser and how that fits in with multi-threading?
Let me tell you where we are. The new parser, I know it's caused a lot of irritation to people because it gets switched on sometimes by mistake and horrible bugs turn up. It really is essential that we have it. I mean, that's not an option to you. The old parser is perfectly okay as long as you don't want anything changed ever in the future. The new parser may not be great, but it does allow us to do lots of stuff which we just didn't have any hope for doing before. Current state as of this morning is I believe the new parser has only one oddity, and I know what the oddity is, and these guys dragged me off to lunch before I fixed it. He said, hopefully. It should be finished by the time I get back to Bath anyway. The technology of that doesn't really worry people. I just say that Stephen did an awful lot of work on that, and I don't want you to think I did this. Stephen did a tremendous amount. I started it, got really disheartened with it, and Steve took it over at the time when I was disheartened. I then found out what he didn't do and what he got wrong, but that's that's what we all do. We play this game. There's a couple of reasons for the new parser. One is actually language changes, and there is actually one language change in the new parser already. There's a while, actually it's an until operator. I'm sorry about that. For those who don't read the mailing list, I come from the only part of the UK, in fact probably the only part in the world, where the word until and while mean the same thing. And every time I lecture to students on C, I have to stop and think, what does it mean? Because I was used to phrases like, wait here while I come back. I get while confused, so it's an until loop, which makes more sense to me. And that's, if you don't like it, change it. The other thing is the new parser allows us to do is to start looking at stuff for the multi-core. Multi-core to me is terribly important. It's important in all aspects of computing, and unfortunately in audio it's way behind the curve. Way back, in my tank warfare days, we actually worked on parallel processing, and I'm trying to import the technology we had from that time. The multi-core stuff at the moment, I believe it works, as long as you don't use what they call channels, and you don't use ZAC. Let's say if you do use them, that's your problem. They won't. I mean, I don't guarantee it will work. Everything else, I believe, and if it doesn't, I will fix. It is completely semantically compatible with the current code. It's not yet switched on, partly because the new parser isn't quite right, and I have a horrible feeling that 5.14 won't have it as default but it won't be difficult to put it in. I mean, it's a matter of opinion. I mean, I take your advice, basically. If you want to play with it, we can make it default. It's all, the code's all there. It sort of runs. The technology it uses involves, well, the paper's around if you want to read it up. It's all about graph theory and reorganizing what they call partial orderings and stuff. But unlike the PD characters, I don't, it's terrible, isn't it? These are users. I don't trust users. We don't trust you, John. That's fair. If you produce a system where you annotate things and you tell people what they want to do, they'll get it wrong. And when they get it wrong, it'll be a disaster. So the model I'm using, and you can tell me I'm wrong, is that it's totally semantically compatible. You don't have to change your code at all. And in fact, there's nothing you can... No. If you don't change it, it will run just the same. It may run slower or it may run slightly faster, but it will run. There are problems to do with loading and load averaging. I know how to fix it. It'll take a bit of time. And I know people keep telling me I'm now retired and therefore I have lots of time, and I haven't noticed this yet. But I've only been retired a month. But there are some problems with load averaging which need to be fixed, but I think it's okay. If we can get that working reliably, the main problem is actually how big the unit of computation is. If your instruments do an oscillator, apply a window to it, and half a filter, basically it ain't going to do any good at all. If, on the other hand, you spend all your time jumping up and down and phase for coding, granular synthesis, and all the other heavyweight stuff, B-bar and things, then it... Babel, that's what I'm thinking of. It may well win. So there's a load problem. The model is actually quite clear. You can say how many processors you want to use, how many threads you want to use, and if you say 1, it'll be just the same as it always used to be, and nothing happens. It switches it out. It appears, I don't know, Michael's done some of these experiments. It appears to go faster for many cases, but not all cases.
It depends on ksumps.
It depends on ksumps. If ksump's big, it wins better. Really. And that worries me, because I know all these performing guys want to get it small. And the whole point of doing this is so you can perform in real time bigger stuff.
Not the whole point.
Sorry. Michael disagrees.
But it's a big selling point.
It's a big point. And we do need to address that. And I have ideas, but it'll happen.
We haven't tested everything, but for instance, you're talking about ksumps of say 500 samples. You're gonna get a lot of gain with that. So in that case, one way that you might think that you will get some gain is that you transform your instruments that had say control rate envelopes to audio rate envelopes, for instance, so that they run on audio rate, and have a higher ksumps. Then your instruments might run faster with sample by sample, so no staircase, kind of smooth envelopes, might run faster than, say, if you had like a ksump, so say 32 with control rate envelopes and just one core. So there is a kind of a balancing thing. So you might have a kind of higher ksumps, and 500 ksumps will give you a certain latency, which will be a certain will be sort of it's a kind of a loss that you might have on that end, but it still might be a good thing. And if your instruments are heavy, and you have lots of those in parallel, then even if you have a certain small ksumps, and you spend a lot of time computing those, and they run in parallel, there's a gain there. So ksumps is not the only thing. It's just if you have a single oscillator, then ksumps is going to be the factor because it's very light.
I think that's about all we can say about it. I mean, it's not been very heavily publicised, partly because I was a bit worried about how buggy it was. I now believe it to be reasonably safe for use.
Well, then, if that's the case, when you do the next release, would there be some easier way in csound or somewhere where I could just tell it from there, or do I have to build it
It's a build-
myself?
No,
build
two
first.
options. New parser and -j, how many cores you have.
Okay.
If you made it, if you built
But if
it,
it's a command line extra that I would just type in from
Yeah.
within
If you-
QC
if
Sound
you-
if
launcher.
options.
if you built
Options,
if
great.
you built it entirely in the multi-core version, then and you made you had a -j1, it would be the same. I think within Epsilon anyway.
Well, I'm just suggesting that that might be a way
Might.
to go.
It's only-
with the
I
next-
think- do that.
I think the problem is that if you enable the multi-threading, you're stuck with the parser. You wouldn't have the option for using the old parser.
Oh, okay.
Yeah,
No.
it really is fundamentally.
What
tied
you
in.
need to do, but you see the old parser and the new parser there depends on which one you're going to be using. So everything is there. It has gone into the multi code. It has gone into the mainstream code.
Yeah.
So in the release,
Yes.
you were going to release, and anyone can use this just by adding, but by using new parser and
So
the
my
number.
question for John then is, if we deliver the new parser, this business about ZAC and channels
Give me 10 minutes.
is only a problem if you're doing a multi-core
Yeah.
performance,
Yeah.
right? So that should be the default then.
I can also, thinking about it, if you'd use ZAC or channels, it wouldn't be too hard to just say, you ask for 4 cores, you ain't getting it. You get 1, which will be safe. The question is whether you want to be safe or whether you want to be dangerous. Alternatively, I could just fix the ZAC, and I've got a model. I know how to do it.
Well, but maybe the first release where everyone gets to try the new parser and discover things that maybe are wrong with it defaults to when ZAC is used. It is the default. When ZAC is used, it switches it out by default.
That takes some code.
Well,
at the
It's just
release,
hard to do that.
Ask these guys. Look,
Yeah.
these are the guys who are going to
I
use
think-
it. I mean, we can make technology as much as you like. What do you want?
I think the
Come
default.
on, what do you want?
I think it's too soon for the new
Tell us.
parser.
Tell us.
Yeah, I think it's too soon for the new parser.
As far
I don't
as a
think so.
default, but it's still there. I mean, it's there for people to use. We won't enable as default, but we will enable as default once we have some time testing it. Then we will probably the next
How are we
release will be
gonna-
the.
The best
I
thing is
use it all the
to have
time.
people use it.
I use it every time. I mean, I
If
only
you put
ever
it out
use the
there-
new parser.
Here's a question for you
Yeah,
guys.
yeah.
If we put
I
this
use it all
out
the
there and it's the new parser by default, then there will be things that don't work. And you will have to tell us, and this will go on for a while. And that would help us enormously. It would speed up the development process, but it would also be painful in
For
some
new
cases.
users, what it'd be like when they run something and it doesn't
I don't
work.
think we can have showtime until we know that this will
Yeah.
run.
Then I
in the
think
most
we need
time.
to have 2 releases.
2 releases, yeah, that's good.
One for where the default is the new parser, and one where the default is the old parser.
There you go.
Yeah.
Beginners could choose
Yeah.
safe,
Recommended for beginners.
safe, yeah.
Old parsers.
Or we have we
It's stable and unstable in the
no, I think it's easier than that. What we can do is we can pull a good number of users of volunteer users who will add in their csound options new parser, and we'll use it for all their use, and then they will be reporting the errors. Still, there's only one release, and the default is the old parser. But then we'll have a good selection of users who'll be using the new parser for us.
We can build it with the old parser.
That's having 2 releases. I mean, you have one for some people and
Can you hear
No,
me?
no, it's the same
Yes.
release.
Hi.
It's not. You don't have more than one
I'm
file.
I'm thinking front ends can also play a role here.
Yes.
They can easily help people enable the new parser and the parallel processing without having them as default for this release.
But
So
Andres, the
front ends
problem,
can help that job as well.
but Andres, the problem is that you can't enable the multi-threading without requiring the new parser.
Yeah, they go together as a thing, but we can have a single binary of all the code in it. You just switch it on or off.
Yeah, that's
Which
what
we
I'm
can.
thinking. There's no.
That's doable.
Yeah.
That would require changing the program structure, right?
No.
No, it's a command line flag or so.
It's a command line flag.
These are all command line
To have
flags.
the old parser or not.
Yeah.
Yeah, it's just you can now you can run.
Oh, wait a minute. So at runtime, you can switch on
Yeah.
Yeah.
the new parser, and only if you do that can you use the multi-thread. That's
Yeah.
fine. I have no
Yeah.
problem.
Yeah.
Okay, I misunderstood this.
Yeah.
But I mean,
That's fine.
what we
Let's
could
do
do
that.
is we
Come on,
could
let's do it.
have under this kind of get a group of volunteers who will say they'll sign up for this program of say I will for our stuff.
So when you
we
say
use.
the default is the old parser, what you're saying is the code will do the new parser, but by default the flag, the
set the other way.
default for
But
the
it
flag
should-
is the
yeah.
old parser.
Yeah,
That's
exactly.
fine.
But that's how it is now.
And
Except we don't
that's
build
what
that stuff.
Actually, that's what I thought, and I don't know why I went down this path. It's nonsensical.
One question. What about to use the new parser but with a flag with a root parser or how?
You can do that as well.
That's how I run it.
Yeah.
I mean,
So
when I was teaching, occasionally the new parser would be a pain, and I'd just put the old parser flag in front of the
if
student.
people know about it and still
Yeah.
the new parser is the default, then it's
Look, I think the question Rory's saying is about what about new users?
Yeah.
There's always a problem of putting people off.
I
Because
think we can't afford to put people on.
No.
I
So
think
I-
we have to be careful and safe here.
No, you know, what's released has to work.
Absolutely.
You know,
I completely
we can't move to a
agree.
new release with faulty binaries because that's.
Sorry for asking this question, but I do not know what does it mean, a new parser, what is it?
Okay.
Okay,
Joe.
there's the internally. I mean, the bit you don't care about, if you're just as it were a user rather than a
Yeah.
techie. The language you specify orchestras gets translated into all sorts of strange data structures internally. The new parser does that translation using a completely new chunk of code. The advantage from my point of view, and it makes no difference to your point of view, it should be identical. It allows me to put new facilities in, more checking, doing stuff which is. No, I won't be rude about Barry. The old parser is written in the style of the way we used to write programs in the 70s. And it's okay for the 70s. I wrote programs in the 70s, and that's great. It's very hard to modify, and a lot of the stuff we now talk about really is very hard to do. Some of the changes, there were some amazing bugs in there, which most people didn't notice because they didn't write silly code. But if you wrote them, you got some really stupid error messages. They were very hard to fix. Some of them got fixed, but they're really hard. The whole purpose of the new parser is purely technological change to produce something which is identical to what we have at the moment.
So what you said earlier was it lends itself to the multi-core.
But the multi-core,
That's an
to do multi-core, we need to be able to put locks in various places and make certain checks and all sorts of weird stuff. The new parser allows me to do that because it's written in straightforward C in a very semi-modern, 10, 15-year-old technology, stuff I understand. To do it in the old parser, I don't even know where I'd start. Just panic.
So this replacement takes us to the next place for all of
It's
this.
a standstill. It's taking one step sideways for a whole ability. And I don't know if Michael's talk about this. If you really want a raise, and don't get me on a raise, getting it so that the old parser would parse the correct syntax. Anybody volunteering?
No.
The new parser, if you really want it, in fact, if I'd had a bit more time last week, I'd have put the syntax in and not told anybody. Because I know how to do it. I don't know what to do when I've done it. I don't know what these array things mean. But putting the syntax in is just, you just do it, isn't it? No problem. Now, that's what the new parser gives us. So if people say they want a while loop, you can get it. I say there's an until loop there already now. It's only in the new parser, and it's just simple code, nothing complex. If there are new syntactic constructions you want, then there's a chance we can do it. So, from a technological point of view, it's what's his name? Nicola Bernardini complained many, many years ago that our parser was rubbish, and he wrote a new parser of csound. Unfortunately, because of licensing, I didn't dare look at it. And the new one was written courtesy of Epicon PVT of India, who paid me to do something else, and in my spare time I wrote that while I was out there. I should be very proud of JK.
Oh, of course.
It's JK did it.
Yeah.
But it's just taken time to get it back into organisation. It's been hanging around my disk for ages. Indeed, there's so many versions of it hanging around my disk in this piece.
So are we in some kind of place with this topic that you guys have started to decide right here at this
I think
roundtable?
I think we know what we want to do. It's because
Well,
yeah, no, I
if
think
nobody's objecting, let's
I
do
mean,
it.
if there's a point that could be made now, we would be able to move forward.
yeah, I mean
that,
I
that we've
think
made a decision that we could anticipate
Yeah.
as
Okay,
users.
this-
I'm fighting for the users.
I think the point has been made that we'll try to pull with a new release, get a pool of users that will tell us where it's wrong, and we'll try to fix it.
Maybe we can ask, how many people are interested in multi-core for audio? I assume most of us are, right? So this is a very pressing issue, right? Because we want to be able to just process away.
Yeah.
So it seems like, having some kind of focus group for testing out these features would be nice.
Yeah.
It must be said also that it's mainly Stephen and John that have done pretty much all the work on the new parser.
Oh yeah, no, that's what you're saying.
Yeah.
What I think this leads into is the next bit that maybe Michael will be able to say a few words about, is what this brings in terms of new language features. And we have been talking a little bit about this at lunch with regards to maybe being able to open up with the way that the new parsers, how the new parser connects to the engine, right? That can be opened up, and if you don't like the csound language, then that might not be a problem anymore. You might be able to be offered a new language to build synth using the same engine. So, and of course,
There's a lot of overlap between the other thing I'm going to talk about, which is performance and new language features and multi-threading, because they all depend on having a parser, and they depend on other things. Regarding performance, csound right now is essentially a Unix command written in C. It's been reworked and hacked over the years by many people to support an API, plugins, and now concurrency. It's been given APIs for other languages internally and externally, and yet the computing environment is leaving us in the dust. The coming computer environment is going to have up to several hundred CPUs in a box. It's going to have even more sophisticated memory management units and floating point processors than we already have, which are very damn sophisticated. It's going to have multiple purpose GPUs, special purpose processors that can do thousands of things at the same time. It's going to have up to several hundred gigabytes of fast memory. It's going to have up to a terabyte of solid-state disk. It's going to have dozens to hundreds of terabytes of disk file systems. C++, C, and Fortran will still be in business and will still be used for systems programming. They will have better static analysis tools for coding. You will be able to prove a lot of things will work, not everything. At the same time, Lua, JavaScript, and other dynamic languages will be as fast as C and C++. At that time, OpenMP and maybe other things that haven't yet been firmed up or even heard of yet will be routine with static languages. There's another thing that's always in the works in computer science that would really simplify concurrent programming, which is called transactional memory. But I don't see that it's really up for prime time anytime soon, so I can't really factor it in. So what do you people want for new language features? People want user-defined instruments that can be written in other languages. They want it to add features to the csound language to make it easier to program, like classes or a native array type, which actually already exists in the linear algebra opcodes. An easier to manage system to set up. You should be able to just unzip a zip file and have everything run. People would like to be able to call opcodes as functions. Developers have their own set of requests. We would like to have a simpler, cleaned up code base. We would like to be able to separate the csound runtime from the orchestra compiler. I would like, and some other people might like, a complete signal flow graph design for the runtime so that you're not stuck without S at the end. I think it would be cool to introduce classes to the orchestra language. Instrument instances should track globals. There should be a deprecated flag in opcodes, but we have to maintain the backwards compatibility. One of the things that is making csound increasingly powerful, and csound has become increasingly powerful compared to its competition. Not less powerful, increasingly powerful. The gap between what you can do musically with csound relative to other systems is increasing, not decreasing. And that is because of the backwards compatibility, because the backwards compatibility means that there's a common remaining library of stuff and it keeps getting added to. And the other systems haven't had the benefit of this for whatever reason. They haven't had as much of this. There's some of this with pure data. And there's a little of it with Super Collider, but not like with csound. So, for now, I think the basic principle to grasp here is that in introducing new language features, every time you want a new feature in a code base, it's a good idea to put in an abstraction layer. And an abstraction layer for us means an interface with a configurable factory. The parser enables these factories to be plugged in to carry out what the parser instructs. So this is one of the reasons why we really depend on having the parser. For now, to get to, for new language features, am I looking at the right thing? Yes. I don't really have that much for now. Finish the concurrency work. Pluggable memory managers might be nice. I think we should evaluate the ability to write some parts of csound opcodes in OpenCL or some other GPU, PU system where you can use the GPU horsepower to do stuff in parallel. For further out, so those are like csound 5. For csound 6 and further out, I think we need to redesign the csound runtime to use the abstract interface factory design pattern with pluggable parts. So you can plug in parsers, you can plug in things that the parser wants you to do, you can plug in instrument instantiators, opcode instantiators. We do this with opcodes now, but the interfaces need to be simplified, separated, and refactored. Right now we have one interface for Python opcodes, another interface for Lua opcodes. There should be something like opcode, blah-blah-blah, language, blah-blah-blah, name, blah-blah-blah, arguments, and then whatever backend you want. You specify the backend. I think it would behoove csound to be more attentive to competitive implementation standards based on what people do with C and C++ for avionics software, scientific data analysis software, commercial shrink app software that's written in C and C++. There's a lot of practice there. So I'm probably going over my little time slot.
Please talk if you have anything else to complement this.
Modules. This idea of having an abstraction layers suggests breaking up the csound system into a number of modules. A runtime that manages scheduling, instrument allocation, function tables. This is the core that Barry Burko wrote. A runtime that is designed as a general purpose signal flow graph. Orchestra parsers, instrument parsers, opcode parsers. Internal libraries could be modularized, like the memory managers, like FFTs, like other low-level stuff could be modularized. And the logging system could be modularized. And that's it.
Okay.
I just wanted to, it's not on your list, but from a user perspective, we need better tables and table displays. I don't know where that comes in, but better ways of displaying the signals. I don't see that here, but maybe it is on your list earlier.
List, but I'll add it to my list.
And And the other thing,
tell us what you need. I
well,
mean,
no. There's no, the way that tables are displayed and kind of
I think it's a-
cascaded, and there's no good spectral thing, and there's no measure. There's no scientific
I'd
measure
say
for
this is a
tables.
front-end thing, and maybe our friend Andrés has something to say about that.
Yeah.
But yeah, I think that's more of a front-end thing.
Okay.
And maybe fixing the API. There are some issues with the way csound notifies front ends about tables. For example, a front end doesn't know when a table has changed.
I guess I'm talking about displays. I've used the word table, but I meant really waveform displays and things, because
Well,
there is a table
front-
issue.
That's a
I believe
front-end,
you, but I
yeah.
just want to
Yeah.
make it clear, because I
Yeah.
think I was saying table, and I meant.
But I mean, this is clearly
And-
something that
It's a
for instance-
csound feature, but not a language feature.
Yeah, so there's a session tomorrow on user features.
Okay,
This is
that's
kind of
where that
more-
belongs. It doesn't belong in this
Yeah.
list. Okay.
But maybe.
But
this
I
is
think
something that-
Andreas is right that the API doesn't support some of those things, so it is maybe a developer
Well,
issue. I don't want to get us too far afield.
With
Cleaning up the-
Max MSP external, you can change tables and also
Yeah, you can do that.
display tables as they're changing as well.
Yeah, you should be able to do that. What
I've done that.
Andrés?
So it's just it's
Yeah.
very slow because Max is slow. It's just
Yeah.
it's a problem.
What Andrés is saying, which is something that it's basically another, improvements to the API, which we, segue nice to what Francois has to say, is that, for instance, like the table part of the API has some missing bits. For instance, one of the things that's missing is that a front end should be notified when csound changes the table, so that it knows, for instance, that it can redisplay, or like for instance, one of the things with csound is that you can't use a table display to display a signal, which you should be able to write to a table and then use that as your table display, but you can't because he doesn't know whether that table has been changing. As far as he knows, that it's been created in the time and it's not going to change. So it's the kind of thing that it's not really big work, but I mean we need to gather all these ideas and put together, and alongside that some work with the interfaces and of the interfaces library, which is, for instance, the csound perform class needs a few extra add-ons to the thread safe aspect, which is basically dealing with tables, and so this is something that we need to.
When Michael talks about, so again, from maybe a user, but maybe a more advanced user, when Michael talks about restructuring the code or the code base, it's always been weird to me that if you wanted to find the C code for an opcode or some other part of csound, it was sort of all over the place. And to find out where, you have to know which .c file, is that what you guys?
I must agree, excuse me, but I must agree with Richard here. You guys are used to this crap. It's not
there is a utility in the system which allows you to do a mapping of where opcodes are there.
Yeah. Why don't we have one header file?
Yeah,
or
it's not
two
that
header
hard.
files?
Because we don't have it because we don't know what the opcodes are. They happen dynamically.
That's fine, but for the
It's called e-tags. You just
Yeah.
go meta x, name.
I use Xcode. I just click on
okay,
it.
all right.
I mean, I grab, if I don't know where a bit of code is, I grab it and I find it.
There's something that Michael did include something which I think is important, and it wasn't brought out explicitly. One of the things I really want to see, and I've been going on about this for rather too long, which is embarrassing because it means I haven't done it, is dynamically loadable instruments, dynamically deletable instruments. At the moment, once you've compiled it, that's it. You can compile another version, you can do something else, but that's it. There's absolutely no reason why we can't separate at the point after the parsing end, before it goes to the machine. We can use an abstraction of what an instrument looks like and instantiate it. We know it's possible because ADI did it. I have that code, but it's proprietary.
Well, I'm just wondering, look, we've just taught all these young new programmers how to write audio programs, and we've told them, or implied, that csound is this incredible resource and library of code that will really, once you understand, it's all in there and you can use it and build things from it. We like to encourage that. Maybe we did. I thought we did. And yet to just look from a standpoint, if you're not I just pop it in Xcode, or, it's just hard to find all the pieces that you need to say, that's all I need to now make an iPad app with csound's oscillator or something like this.
Yeah, but I mean,
it's hard to find. I'm
you
just
see-
saying, and maybe you guys know the tricks. I'm just asking either that you tell us the tricks we need to know, but it still seems convoluted. And I've always felt it was convoluted when I looked at all of the code, all the bits that we would link together to make csound. Like, it seemed arbitrary how it grew. And I'm saying, if you're really now thinking about all of this, maybe
Well,
that's
it's
too
just
much
the
of
way-
an effort. I think
well-
we've talked about it before. Maybe it's too much an effort. And again, I
You
don't.
can have the
Michael
dictionary.
raised the point about restructuring, and I only bring it up now for that purpose. I don't want to take us off core and off course.
Yeah, the dictionary is there. I mean, I have it.
I mean,
I use it.
what you're looking for, because I don't really understand, because you're looking for oscillator code, for instance. It's very easy to find. I mean, there maybe, it's very easy to find where each opcode is, if you, like, Stephen uses an IDE and he does that there, but I use the command line and I find anything that I can look like in
Yeah, I know
very
it can
quickly.
be found, but it's in 4 places or 3 or 4 places.
No, it's one place.
Okay.
One place. The code like for an oscillator is in one place.
Yeah, I
But
know
what
that.
isn't there, I'll tell you what isn't there, it's because the opcode is only part of the whole system. You can't just get an opcode and say, no, it's going to work on its own, because it doesn't work like that. It depends on lots of things from the system, which is how the csound 5 is designed.
Yeah.
Now, if you want to make, the things that Michael was saying might go some way in, for instance, of separating the opcodes, making them more self-standing. But this is kind of the kind of arrangement that will be needed when we say move to this new structural code, which it might be comparable to, for instance, how things move from csound 4 to csound 5, because the code is completely different.
I think it would be about as much work, maybe even more.
But I mean, it's something that if it's recognized to be something of value, then we should make a list.
I think if we want the level of abstraction that we're talking about, it's essential.
Yeah, and now I understand what you mean, but it's not really defining the code. It's basically separating, making an abstraction of what a no code is, and making it kind of less linked to dependent on the engine itself. So having an interface between the opcode and that is more defined between the opcode and the system. But I'll tell you
Am I
this.
right that
This
they would
yeah.
all feel
I'll
like
tell you this.
plugins?
This will be then. This will be a unique thing, because none of the languages that I know of, say csound's sort of companions like PD and Super Collider have this separation, because they all depend on stuff that is in their engine, and they work. It's pretty much the way csound is at the moment. So we might consider that is probably a wise thing that will enable the system to be more flexible.
Well, there's a downside to it as well. I mean, it is a lot of work. It distracts us from doing other things, and to get it to work properly may take X amount more than we think. There's always a risk in making a change on that order. There's always a risk.
Yeah, we'll have to. I think this is the kind of things we'll have to decide in terms of what will be the main targets. As much as I guess when it was 2002, 2001, you made a list of what was your wish list for csound 5. Maybe now is the time for us to make a more complete wish list for csound 6.
Oh, I almost just heard one.
Yeah, no,
Well, we had one from the Linux audio
yeah,
conference,
yeah,
actually.
yeah, we do have one.
Just hoping it's going to take as long as the other one to match.
Well, I mean, there's priorities, right? You move through it.
Well, unfortunately, with change on this order, particularly any changes that we make to the runtime or to break apart the system into independent modules, these are fundamental changes that require many parts to be rewritten or adapted, and while that is happening, there isn't really that much else you can do. So that's one of the risks.
One thing we could do, I mean, it might be a good thing of planning, is to decide what are the features, the final features of csound 5 that we want to do, work on these, and bring the csound 5 to the state whereby then we can put it into kind of a more maintenance mode, and we start looking at the branch of csound 6. But like, what would be like what? Then that's a good question. What are the main things that in csound 5 that are not going to be that we want to do now, that won't need a kind of a big change? John mentioned one, which is the loadable instruments, and being able to compile them and then compile and load them. I think that's probably a big priority now. This is on top of the things that we said about getting the
live coding. That's what John was just saying to me.
Not that I want to do it, I'm quite clear. I think live coding is complete rubbish for that.
Do live coding and sort of not be left out of the live coding wave.
Yeah.
It's true, and
I always thought when I turned a knob I was live coding, but
You are.
wow! So now I could type it instead of turn it. So
I guess the things we're telling is like talking about this, and on top of what we said before, which is getting the parser right and getting the multi-core right, because that's absolutely right.
That'll happen by the end of the year.
Yeah, but then the thing is, we're to see whether we can do the loadable opcodes. What else would we think? Making a change to the API to be able to separate the parsing from
Maybe before we decide what goes into csound 5, we should do the session on the API.
Yeah. But I mean, this is a good thing too.
Can I just
Yes.
mention, Michael also just suggested adding arrays, which I think, at least for me personally, is much more important than
There are many different definitions of what people mean by adding arrays. And I made negative comments on the mailing list, and I stick to them. Sometimes the semantics people expect is not obvious. They think it's obvious. It ain't the semantics they'll get unless something's done very cleverly.
So
Some of the other things being suggested, which
what do you need?
other things suggested, which are very nice, are a heck of a lot of work. There's so much more work. You can't imagine how much it is. It's like writing the whole of APL. For those who know anything computer science, and sorry, APL is a joke among computer scientists. I mean, it's more or less the same as writing the whole of APL as a subset. That's a lot of work. And I mean, yeah, okay. I've got nothing else to do.
But
blah,
what's
blah,
the
blah.
reason
But
that
is
you
that the
think
right
it would
thing
be
to
so
do?
important? I
Is
mean, let's
that
just
important?
find out for this.
Let's hear the use case for arrays
Please.
here.
Yeah. Why would you?
Would that be useful for dealing with FFT data, and you can manipulate tables? If you can convert arrays to tables and vice versa.
Okay, here's the truth.
So you're talking about arrays of values.
Here's the truth of the matter. There already is, in csound, a linear algebra library that can do what you're asking for.
No, I
It's not
am
built on all systems.
kind of familiar with those, but there's no documentation at all. So maybe that's all that needs to be done
I-
about it, documentation.
The other question about arrays is there are two sorts of arrays which people sometimes confuse. There are data arrays. I mean, if you wanted a k-rated object with an index, that is pretty close to trivial. Not quite trivial, but it's pretty close to it. Syntactically, it's easy. Semantically, it's a bit of a pain. If you want to have arrays, opcode arrays, that's a different game.
Opcode arrays are different. It's
They're
not
very
what I'm
different.
talking about. Yes.
And sometimes people don't distinguish them. I mean, the csound opcode is in fact an object. And people don't always realise it's an object. It has internal state. And there's always the question, if I say oscil, do I mean that oscil, the bond last time? If you apply a filter, do I want to remember the last version of,
But I don't think that's what you're asking for here.
What do you want?
He wants to be able to manipulate
if you would like
spectral data.
If you would like syntax, just purely syntax, to be able to read out of a table as if it were an indexed variable. Well, give me an idea of syntax, and we can talk about it this afternoon. That's not difficult. That really isn't difficult.
It's a different thing. You're talking about to do operations, not to say spawn like have a loop to spawn 300 oscillators. That's not what you.
No, I think I know.
But then the supercollider does.
I think I know what you want. You want the bracket operator.
Yes.
He
But I
wants
mean,
the
if you-
bracket operator.
Yeah.
If that's what you want, as long as you make them square, as long as you make them square for syntactic reasons.
Yeah. But
They're
I mean,
yes, it's a matter. That's easy.
to be honest,
Quite
like
easy.
that's fine. But if you wanted the array of spawn out, you can do it. with recursion, which is exactly the same thing, and it's not difficult to do, and that sort of has, you can have as many as you like,
You better need that needs documentation. I suspect. I mean,
It's in the manual, but I can write a better.
In the manual, I mean real explanation documentation.
Yeah, I can do that.
I go back to the display thing, which belongs in a final version of csound 5 that puts scale marks, whatever. Menno and I both love working with Max with csound because finally we can get beautiful displays there, but then it's not csound in a way. It's like we're cheating it.
But the API,
I'm just saying
API's
that
there.
if you're going to close and then say maintain, then I think that that's an important part. It's a weak link. It's a crutch that we have that makes our language as powerful and beautiful as it is.
But we
inferior.
See, we don't understand what you're talking about because one thing
I want spectral displays of my waveforms. I want to be able to.
well,
We get them a little bit there. You
That's
can get
the
them up there.
because see, these are things. Because sound is we don't do front ends because it's not part of our development to do front ends. What we do is support front ends from the API. So, for instance, Andrés has a problem. His tables don't, he can't do something with the tables because the API does not support it. But we can then do something to do that. We can create an API support for what he needs. But the actual display is nothing to do with us because it's him. And if you want to do that in MaxMSP or PT or whatever, that's also fine because it's a front end thing. What you're using is the MaxMSP as a front end and csound. Because that's the main thing we have to be thinking about, is that csound became so specialized as a sound engine and as a synthesizer and as a means of making sound that we just left all the graphics out because it's not part of it. But
I think we need a spec for what the API needs to be extended by.
Yeah,
I think Andrés is his problem to tell us what the spec is. He's smiling.
Yeah. I'm giving it a think. See how I can think of something.
Well, the little small example, even just a trivial one, and it'll only take a minute. When you're using from the terminal and you just have it do displays and you're doing scan synthesis and you display the masses, you see that update. When you're doing the same thing from within csound, it shows up at the bottom of a menu. By the time you get to that menu item to see the scan masses updating or moving, the instrument might be over or whatever.
Well,
it's like it's like appears in a separate. I'm just saying
he has to solve this in his front end.
But there might be some things he's missing to give him the.
If there is, we will add it to the API, and that's when Francois can
make
say your piece.
So the API has been there since version 5. It was one of the new abilities of this version. Basically, API is written in C, and this is important because it's mainly thing for C developers. That means if you need pointers in and out for C developers, very easy. We will see later that with other languages it can be complicated. The API has about 11 main topics. The first one is instantiation. That is, you start a csound session, you get an object pointer, and this gives you an entry point in all the csound machinery. Despite the fact it's written in C, this object pointer is in fact like a sys pointer in C++. That means that the API is object oriented. Even if it's not written in an object language, it's really object oriented. Then you have some performance functions. I think those are the functions that are the most used in the API. Mainly, you have a k-rate loop, and you can insert your actions as a programmer within this k-rate loop. I think that's basically what is done in qtsystem, for example, when it's playing in real time. You have some function to get attributes, K rate, S rate, number of channels, csounds, and so on. You have some score handling functions. Functions for messages and text. Some control and events function. For instance, you can launch C-score event. You have a bunch of functions about MIDI. Function table display. We'll discuss that. Apparently, it's a bit problematic actually. Some functions to list opcodes, to insert new opcodes. A very short section called miscellaneous functions. And the last one, it's the biggest one. It's called real-time audio playback and record. And in this section, you have all the systems about channel. I think there are 3 different systems actually. One by value, one by name.
Yeah. And one by one has an internal list of channels, and that can be used inside csound to communicate for instruments. And then you have the other 2, which by number, and then another one with callbacks.
And historically, those different means were brought by different developers, I think.
Yeah. Yeah, it was because it's finalized in degree, basically.
But I think there are 3 very useful, so we should keep them. And in this big section, you have all the machinery for multithreading to start a new thread, for having mutic sets or lockets. So this is quite maybe the most complicated part of the API. Over this C API, you have a C++ API. The basic C++ API is just a C++ class that gives you all those C functions in one class. So it's more clearly object-oriented. I think it's just for convenience. But then, you have another class that is very important. It's Season Performance Thread. It's a C++ class that presents to the user the most important part of multithreading. You can launch a thread, you can play, pause, stop. It manages automatically all the messages in a queue manner. And you can even have insert in a case sample loop callback function. And with this callback function, you can do all the things you want. Then you have a level higher, a kind of more sophisticated class. It's csound file that adds some functionality about scores, reading scores, CSD, orchestra scores, clarity, and so on. And upon that, you have another one that's called CPP sound. I think it's for your algorithmic system.
Yeah, actually, I developed that at the same time as other people were developing some of these other interfaces. And there's some duplication that's awkward.
So you see this those different levels. Basically, under the hood, it's still the C basic API. And the C++ adds a lot of convenience tools. And then it's getting more complicated with other languages. There are wrappers for Python and Java, 2 main wrappers. And those wrappers are automatically generated using a tool that is called Swig. It's really a convenient tool. It makes really good jobs. But it gives 2 really awful structures sometimes, with very long name, underscore, underscore, suite type, underscore. And so when people are programming in Python or in Java, sometimes it's difficult for some parts of Java, especially for the parts when you have to deal with pointers. It's a bit difficult to figure out. For example, I did some work in Python. I wanted to have a pointer directly in an F table from Python. Because in Python you have a module that it's called NumPy that gives you a lot of facilities to arrays. And the idea was to have a pointer wrapped in Python directly in the C buffer of the F tables. I could do it, but I had to work about 1 week before I could manage how to do it. It was quite complicated. There is too a Lua wrapper.
A Lua wrapper, yes.
But with your new job with LuaJet, I don't think it's really useful now.
I don't agree, but that's because the Lua wrapper provides a wrapper for CPP sound, but it also provides a wrapper to csound AC classes for algorithmic composition. Not a part of the csound core, but used with csound.
Okay. So, but if you just use the csound core, maybe now it's easier to do it with LuaJet.
It's probably 6 of one, half a dozen of another. If it turns out nobody's using the Lua wrapper, I wouldn't mind getting rid of it and just using LuaJet and the FFI. You're right. But if people are using it, we don't want to throw it out and discombobulate people.
I've heard too of an Haskell API. I don't know it. A Lisp one.
There's a Lisp one.
There's a Lisp one which I created, and maybe there's another one that's in there.
But I've heard of an Haskell one.
Yeah, there's a start of Haskell one, but I'm not sure at what stage. It's not part of the. It's not part of the csound code. It would have been done, as a third party.
And I myself wrote an objective camel wrapper, but I never published it because I had problems with the multi-threading part. That's the main reason is because the garbage collector in objective camel is not multi-threaded. And this is a decision of the objective camel developers.
That's not a decision.
They prefer to use processes.
Not a good decision.
Yeah, the objective camel garbage collector anyway is a bit strange. For example, if you have a 32-bit integers, the last bit is used for the garbage collector. So you can choose only 31 bits for your integers. If you lose 1 bit.
Sorry, but
there are a lot of strange things like that.
Been there, done that.
But I spoke of objective camel because despite those facts, I think it's a very nice language because it has procedural, functional, object-oriented. And I didn't know Lua. And when you wrote your articles 2 or 3 weeks ago, I just bought a book about Lua and looked at it. And
programming in Lua?
Yeah. And I found in this book a lot of techniques I had learned with objective camel. But I would say it's an easiest way to approach those techniques.
It's very good. It's very easy, and it has the object-oriented, the functional, and the procedural stuff in a very compact form. Yeah.
There's another wrapper which is a manually written wrapper for Tico. It's called Tico csound, and it's there. But that's different because it's manually written. So
it's not Swig.
Yeah, it's not Swig. No.
So as it is, the API has some dark points, not very clear. For example, the first function in the API is csound initialize. And most of the time, if you use csound create, it's enough. You don't you don't have to call csound initialize because csound create calls it for you in a default way. In fact, when you read the source file, you see that csound initialize as a utility with certain flags. But it's rather cryptic. It's not really explained in the documentation. There are some points like that. And about 2 or 3 months ago, there was a discussion on the list. I think it was about those arrays needed, and someone answered that we could use the API to do that. And then the guy who had asked the question said, "Oh, the API is too complicated for me. It's not well documented."
Here.
And then Michael answered, "Okay, we have a tool like Doxygen that generates automatically the
It does, but
documentation."
it's too complicated.
It generates precisely the stuff that you would get just by simple.
In fact, it depends on the comments in the source
I
code.
use it all the time.
So if
Difference in style.
I don't find anything useful.
I think if you're a software engineer, the source code is enough. You get everything you want. But if you're not a software engineer, it can be complicated.
I don't know if Doxygen makes it less complicated if you're not a software engineer, though. That's the thing. I mean, it doesn't help beginners to intermediates who want to take advantage of trying to use the API. Doxygen sort of tells you the facts, but I would agree a little bit that it's like reading the code again. It's not. It does organize some things for you, which feels nice, but I don't know that Doxygen helps me get in.
It's a reference. It's not a guide.
That's a reference.
I'm going to put my hand as a user. I found the API absolutely opaque. We have failed now, I think, 3 times to use the Java API to do something which I still consider to be pretty ordinary. And that's because the documentation is awful. Swig is a terrible program, actually. I'm sorry. It generates incorrect C in places, which always annoys me. I had to go and hand edit the code at one stage. And I find the Java, I'd love somebody, I mean, speaking as a user, I'd love somebody to actually document the Java API so people who just know Java could use it. We were doing stuff on agent-based control of audio. And all the agent people do all their stuff in Java, apparently. And between us, we got absolutely nowhere. It was a disaster.
One of the problems I remember from what you showed us, it's the arrays, the pointers thing, which is when you go from C to Java, you have this funny translation through Swig, and it's hard, but you can do it, and but you just have to know it. You have to again document it well, and maybe what you're talking about here really is that we might need to be thinking of documentation project.
I think there's 2 problems. I think the API is over elaborate, and I think there's a documentation problem.
For the documentation problem, I think as it is, the reference is good. Every time I have to look for something, I just take the header files and I find it. But we need some examples. We need examples. Yeah, but concrete examples.
Yeah. But maybe that's so for the C API. But like if we go to the wrappers, then people might stumble on things like, for instance, especially with the Java.
There are code examples in the examples directory that illustrate a lot of these points.
But it doesn't illustrate the pointer stuff. No, that's the trouble. I mean, it told me all the bits which are obvious.
It doesn't. You're right. It does not
illustrate the bits which are obvious, like I can start
how to handle the pointers in Swig Java wrappers.
I think the examples should be centralized in an organized document, because there are a lot of information. You can find a lot of information in the mailing list.
Yeah, I set up a wiki page, and there was a mail on the developer list about this for documenting API usage. And then I sort of set up the structure of it, and then haven't had time since to fill it out. And I think the idea was to have canonical examples for I want to build a program that I can take audio in and out, and this would be an example. And I want to write a program that does this, shows an example in every language that we have our output for. But
that's a really good idea. Have the same example in different languages.
Same example in different
That's
languages.
That's what I was trying to do in the first manual chapter about the API. But I only took 3 languages: C++, Python, and Java.
Very. I don't know if we need the wiki then, if we have it in the block manual, but.
There's another point I think is really problematic. Is the way it was first written for C programmers, clearly. I take a concrete case. There is a function, it's called getTable. So it returns an integer, it's the length of the F table, and you pass it a double star pointer to have in written in the argument list the address of the buffer of the F table. This is typically C manner. Yeah. And if you try to adapt these functions through Luagit FF5, for example, I couldn't actually figure out how to do this.
I think we can get it to work.
We spoke about
because
this morning,
but that's because the FF5 thing. But it would be very awkward, for instance, if you use Swig. If you try to find the Java wrapper through Swig, but for that it would be a pretty awkward thing to do.
I did it with Python, it worked, but it was a bit complicated.
Swig manufactures all the machinery for doing this stuff, but it's very poorly documented at Swig how to use these things.
Yeah, you have all the directories and those things as well.
But if we take this simple case, instead of having one function that returns the length of the table as a written argument and the pointer to the buffer in the argument list, we could have 2 functions. One that returns the length of the function, and another one that returns the pointer. And in this way, it would be more easy.
It would simplify the maintenance of the wrappers if there were never any returns in the argument, and everything was returned as a value or a pointer.
So maybe we could do this, but then there is we break the backward compatibility.
No, we keep the existing stuff,
Yeah,
and we define new interfaces, probably completely new interfaces.
Tell people not to use the old stuff.
So I think there are two
deprecated, yes.
2 actions that we can take from this. One is from the point of view of the technology, to refine the API so that it gets wrapped in a more user-friendly way for other languages. And the other one is to see whether we can have a documentation project. Maybe we need to have a reference manual, the same way we have a reference manual for csound user reference manual. We need to have a developer reference manual for the API.
Are we talking? Can we discuss maybe features that people would like added to the API as well?
Absolutely.
I mean, this is what we want. Yeah.
Discussed about having information sent from the API about updated F tables. So what about passing csound orchestras as strings to the csound initialized functions or things like that, rather than having to keep reading from the file? Like I guess other people have some other ideas about improvements that can be made to the API.
So what Michael already does with the C++ interface, you want this to be moved down one level.
Yeah, so I know Michael's CPP file or csound file interface, you can send strings and stuff like that, but it's still right into disk. And then it passes it because.
Well, this is something to do.
This would not be necessary if the score parser could read from memory.
Okay. Is that the way it's going?
Nobody's asked for it.
Yeah,
I mean, there's no reason why it can't. I mean, it's just.
The thing is, we'll need something like that because if we ever want to run csound in places outside of the PC, and there are security concerns and security restrictions, right? So, like I'm thinking mobile phones and other places, then we'll need to have a way to do everything in memory.
We can do that already. I mean, the mechanism is in there. basically the way macros work is they read from memory. The moment when you open a string, it opens a file. And the rest of the code has two ways of opening files. You open real files or memory files. It's only a question of deciding how to specify it. The code's there. Nobody's ever asked me for it.
At present, if you're installing some software on, say, systems that are administered, some kind of network administration or something like that, and sometimes if it has to write a file to the C drive, it'll be, security.
Well, think of spec.
Yeah, okay, well, we need to gather. So, I guess, in addition to the things we said, arrays, loading the instruments, and the other things about the parse, this list of improvements to the API can go into csound 5.
Yeah. We should
go into csound 5. And we may be, I think the next thing to do is an exercise to gather from the API users, which we have many, and gather kind of the wish list really, and what needs to be done. What they would like to have, and that's a good kind of target for next release, for instance, because it's something I can see that is kind of achievable in a kind of very short space of time. How do you feel about that?
Yeah, I think we just need to find what we're going to use to collect all the requirements and then announce it. And then, I mean, we can use a wiki, we can use the bug tracker or something. We can do all types of things to collect all the information.
I think the wiki or a shared Google document would be the way to go.
Shall we have a short break?
Or what we can do is, because we already covered the csound ideas, what we want. It's maybe we could just finalize by taking what's.
There's actually one thing I'd like to add.
Yeah, okay.
Something quite different from what's on that list. Every so often people complain that csound doesn't do X. Can you, if you have such a complaint, can you actually send it to the mailing list? Because I'm talking about not talking about these big issues. I'm talking about opcodes and stuff and extra options. Because quite often I get up early in the morning and I can't talk to people, but I can talk to computers. And sometimes you just have this spare time, you want to do something. And if there's a list of little things to do, some of them might actually get done. What I can tell you is if you don't tell us, they will not get done unless you do it yourself. Now, do it yourself if you want to, become a developer, get all the stuff if that's what you want to do. But if you want this stuff, just ask us for it. And I know Pimon's got something he asked me for in Huddersfield, and I haven't done it yet. I'm sorry.
But there are so many things I asked you and you haven't done them.
But there's at least one I know about. But I'm talking about the small things, and the small things are fun. They're things you do when parsing. At least I do. I just like writing code, particularly easy code.
Easy code is the best one to write.
Yeah, that's right. And so if you really want something, just ask. And if you're embarrassed about it, send it to me privately rather than on the list. If you don't want to make it public, and I'll tell you why you can't have it. But that's just a general plea. Please keep telling us what you want.
And also, if any of you feel that you'd like to have a go at development, we're very happy to welcome any new developers to the team. At the moment, who are the active developers? Can you think, John? Because you're the administrator.
Myself, Michael.
Well, Matt Ingles just added those Arduino opcodes.
Matt Ingles does stuff, but he doesn't actually do it directly. He does it indirectly. You do stuff. Stephen does something off and on. Andrés does stuff. I'm bound to miss people. That's the trouble. Every time I think about it, I always miss at least 2 people.
No, it's surprisingly small, actually.
Yeah. About 5. We're about 5.
There's a very large number of people in the developer list, but the number of people who actually develop at any given time is quite more the order of 7, I'd guess. Yeah. A moving 7, but about 7. Yeah. On the other hand, if you really want to do something, there are people, I'd say they really want to work on something, some aspect of it. We can give you access to it. There's no problem. If you don't like what you do, we can throw you out and delete everything you did. There's no problem. But
well, when does Thank you, John, and we'll do that. And when we can find the opcodes, we will all become developers. When we can get Git to work right on our Macintoshes, those of us who have them,
just change to a proper computer.
An Xcode project.
Change to a proper computer.
We might be able to do that. And then lastly, when can we expect this release that was promised before this conference?
I tagged it just before I came here, and then somebody pointed out that my tagging was wrong. No, it was a guy in, and I untagged it this morning. As far as I'm concerned, the code is fixed, unless anybody has anything they really think needs to be done before we get it out.
For the Windows installers, I need to enable Python Qt, and I need to replace the OpenMP code in the Lua opcodes with pthreads.
How long is it going to take you?
After I get back home, which I'll be active when I'm back home on Tuesday. A couple days after that, probably.
So by the end of the next week.
Yeah, in a practical sense, I also need to run some tests. So I would say I can have this done at the end of next week.
Okay, but then there's a few things I might slip in, like I might put the ZAC and
the array, the bracketed.
The bracketed stuff might get
array operators.
Array operators into tables. Array operators into tables, I think, would be easy.
That would be correct. So would that mean that then you can say multiply two tables together?
By multiply.
If you loop over it using the brackets, certainly.
Yeah, you have to loop over it. I mean,
if you want to multiply, just multiplying wise, then use the linear algebra codes. That's what they're for.
We'll talk about exactly what you want.
Sure.
With
the linear algebra, are there any plans for documentation? Because I know it seems very powerful from just looking at the manual page.
I'm afraid there are no plans for documentation. Because I have plans to compose. I'm sorry.
But then it's
Is there anyone who will understand it and be able to kind of...
I think anybody who carefully reads what documentation there is and knows something about other linear algebra libraries would be able to document it, certainly.
And don't we have our manual maintainer, your manual WizKid?
I have to say that I am very much a user.
Yeah.
So I just want to make music and make sound with it. And the stuff I heard all afternoon is 95% I do not understand.
Yeah, but I mean, you might be able to work with Michael basically.
I can help somebody out. If somebody wants to produce better documentation for the linear algebra outputs, I will certainly help them out.
I would offer my services, but I don't even know what linear algebra means. So I don't
Well, it means a lot of things, but in this context, linear algebra means a library for a programming language that will perform arithmetic on matrices and maybe decompose matrices. And that's what the linear algebra opcodes do. So you can multiply vectors by vectors, vectors by matrices, matrices by matrices, and you can solve linear systems and do eigenvalue decompositions and stuff like that.
But nobody knows how.
Oh, come on, everybody's done year 2 algebra and understood it, unlike me.
There you go. Okay, well, we seem to have a good sort of list of things to do, and we'll get this release done by the end of the next week, and hopefully, a few extra things that you might want to ask, we might be able to fit them in.
So is multi-threading now going to be released?
The multi-threading is really, I understand from what I understand. The code, it's in the code, it's not built in the normal releases.
Yeah.
I'm taking the view that as of tonight, I will change my standard things to the default is that it's built. And I might even put a thing in the parser saying if you use ZAC or channels, before I get to work out how to fix it cleanly, you'll get a warning message saying that you are playing dangerously. But something like that. I think we can do that.
Yeah, that would be effective. Well, it'd be easier once you parse the tree and then you're going through the tree.
Exactly, yeah. There must be a place I can do it. Yeah, there's places to do it.
Okay, so we'll close our final section of the of this session with some sort of thoughts on the csound design philosophy by Stephen.
Yeah, I just wanted to talk. It's sort of interesting. Actually, this conversation has been sort of, as Menno said, like probably a lot of it's a little over the head for the users. It just made me think about being a developer, and when the developer discussions goes to the users mailing list, how a lot of times it's like, I can imagine it must look like very cryptic.
My students freak out.
Yeah.
They all say, why am I on the csound mailing list this semester, Dr. Boulanger? All they talk about is...
We've gotten better about moving things back over, though.
Yeah,
So
I try to do a kind of to hint, let's move this to the developer space whenever.
It goes that way, but...
Yeah.
It's interesting though, right? So from the developer's point of view, all of us are likely to be users as well, right? But it's not the other case, right? Not all users are developers. Not even just of csound, but maybe of normal programming languages like C or Java or anything like that. So in terms of like the design philosophy, this section has been sort of interesting to think about. It's like, what's the motivation and how does this group work together? When and just thinking about the past, the history of csound, a lot of times there's been a lot of hands involved in csound, right? And lots of little bits of code contributed by so many different people. And to some degree, Barry created the first csound, right? And he had like a singular vision. And after that, people have been adding on things over time. But, and then sometimes we have people who come in and contribute a lot of changes and make a very solid singular change. And that becomes a very, singularly thought out part of csound. Sometimes now, recently John and I have been working on the parser, and that's been great because we've been able to communicate with each other, and he can fix things that I break, and vice versa, and that's great, right? But most of csound has been really about individual people doing different things, right? Oftentimes to scratch an itch, to I want to add this because I just need a new feature, and I'll add this because someone else talked about it on the mailing list, and we'll add it. So I guess we have, recently I guess we as developers have been met more often. I mean, at the Linux Audio Conference we got together, and it's been really great to discuss. Because from our point of view, there's a lot of internal things that we're interested in changing and modifying, and things that the user would never see, but will eventually affect what the user is able to do. And that kind of conversation is a lot of fun for us who have been trying to look at different parts and trying to coordinate and work together. I guess I think I just really want to talk a little bit about that aspect of the developers here, and also the relationship with the users. I guess I would be curious to know, and I just ask the audience, how many people have looked at the source code of csound? Okay, maybe like one. Yeah.
Everybody up here.
Everyone here. Yeah.
Yeah,
it's interesting. I find that I would love to see more, because I've noticed that we actually don't have that many developers right now.
I will say that when I was only a user and not a developer, I frequently looked at the source code.
And that seems to be more the case when I started csound 10, 11 years ago. Using csound, there was a lot more people who were both using and developing, or at least were developers. So they were able to look at some of the code and figure out, at least on the lower level. And sort of the last, as computing has changed over time, there are less people involved with csound who are also programmers. And then even take that next step is they're programmers and they're interested in csound's programming. So I think in terms of tools, we're using Git. That's pretty standard now, right? And for development,
it's become more and more standard in the last few years. Along with maybe Mercurial.
Yeah, but almost all the other big open source audio projects are using it. Using Git. We have sconstruct for the make for building. Recently, we've been also I'm blanking.
Philippe?
Yeah, Philippe. Have been using CMake which allows us to use things like Xcode and Eclipse and other IDEs with building and working with csound. I don't know. Yeah, I know. Well, that's a problem. Yeah. Yeah, I don't know if there's any comments or anything people have to. Is there anything else to really say about this, or?
Well, I think one important thing to say is that one of the guiding principles of the csound development is that.
I just wanted to know if we were supposed to take something, equipments, or...
No, everything is there.
Oh, everything is there. Okay, thank you.
Did you have your rehearsal?
We have our rehearsal at 6.
Okay.
Habt ihr euch jetzt gegen Pause entschieden?
Nee, ist noch nicht so klar.
Shows something about whether this is the right way in getting a good system, or it's this, or it doesn't.
And it actually goes back to what I was saying earlier. If you don't tell us what you want, you'll get what I want. And I don't use GUIs, and I tend to write algorithmic stuff. So that's what you'll get. And if you don't want that, tell us. Stop me, But if you stop me writing my opera,
I think having musicians involved in development has been utterly essential. Barry Vercoe was a musician. He created a really great piece of software, and when you consider what was available to him when he did it, it's extremely impressive.
And I think he was working on his doctorate at the time and writing giant chamber operas.
No, I must say I wouldn't like to have professional developers who weren't actually interested in using the stuff. I know I'm an amateur in this game, like totally underqualified compared to everybody else on this panel. But I do use it. I really do use it. I teach with it. Did teach with it. And I haven't written much since last week or so, but I do use it.
And I think it's. I guess this is something that will help us move forward to the next. To complete these things that we need to do and move to csound 6, because we're keen to get it right. For it should also enable us to do our own thing, and expand the things we do. But maintaining the dialogue with the community is very important. And
there's another aspect of future development which I didn't mention, but I probably should have mentioned, and that is that the computing platform for many, many people will be a mobile device. A smartphone and a pad of some kind. csound is not best suited for running in this environment at the moment. Now, what's going to happen is the environment is going to give on running traditional type apps to some extent, but I think csound has to give some too. And I think this idea of running the score from memory would be really useful there.
Yeah, I believe it to be pretty close to simple. I just hadn't thought of doing it.
Love to be able to run csound on our iPads.
But one of the problems with that is how do you create a monolithic csound to run that?
I don't see that as being a bigger problem. I think we could easily do that.
Does it in any way relate to Barry's fixed point solution? Does it?
No.
Does it rely?
No,
on
that's in the past.
That's not the right.
That's not the right way.
It's not the right way.
I just was curious if there was anything to be gained from that. Good to know.
It's very. What he's done is very clever. I believe it to be not the right way to do it.
Good.
And technically, it's clever.
Is it a bit of a goal then to try to get your Android version of csound or your iPad version of csound?
Sorry, be on the table. Look, don't say it, because if we say it, they'll think we'll do it. Yes. Of course we want to do it.
Well, no, it's important to know.
Of course we do. I mean,
but is it better to think of a way of I forgot who was saying it today, of projecting some parts of csound. I think it was you, Michael, who was saying you could send the interface parts of, tables or something to the pad so we could control our csound better, like you do with Touch OSC and all this stuff.
We can do that with OSC, but that's not what
I'd rather not use someone else's thing.
Yeah. I mean,
what is the advantage of running csound on an iPad?
People have their iPads on them. They don't have computers on them. That's the advantage.
But what is it? How much can't monitor properly. There's not enough power probably.
There's plenty of power.
It may not be enough for what you want to do.
If we could sell
a lot
it
of
through
people.
the App Store and use it to raise money for the csound
Well, we can't-
Foundation.
I don't think we can
for a
sell it
buck
from
a
the App
pop.
Store
you
unless
know?
we change it.
But
We have to change the license if you want to sell it.
There are
on the
lots of
App Store.
reasons why. I mean, I'm not an iPad or iPhone person. There's lots of reasons why that Android has lots of reasons why you might want to use it. For lots of silly reasons, including things like installations, demonstrations, getting students excited by it. You know, yes, I'm still going to use my 4-core AMD.
Frankly,
64-bit, but
if I had a 7-inch pad with Skype and LuaJet on it, I wouldn't have a computer, even though I am a csound developer, except to develop csound.
And we can't forget that that's a pretty interesting controller. You know, that there's
Okay,
all that.
But what
that integrates with maybe the
So
system.
the control can be used to send OSC messages.
We can do, I know,
right?
I do, we showed that last night.
So how can we get around the problems of dynamic linking, the problems of
We don't actually need the dynamic linking to make an iPad csound.
So
we've just put all the opcodes and everything we need in one binary, and that's it.
Well, what about like live sound file and stuff like that? You know,
No, we would have to write our own sound file out of it.
oh, we just took that out.
we can statically do it. The sound probably be easy enough because to do static linking.
The license is a problem.
No, we're allowed to license. We are allowed to do it statically.
We are. I had no idea.
I believe we are. I shall check with Eric, but I think
we can't do
we
iPad.
are.
Like
because
we can't.
there's rules.
We can't distribute it through, say, we can have it on iPads, but we couldn't distribute through the store because the LGPL is not compatible with the.
Do you know how much it costs to get a proper license for a live sound file?
The LGPL is compatible with the App Store.
100 Australian dollars, once off. So
Okay, that's not a problem.
So if it's a real problem, we'll just have a whip round.
That's not a problem. Okay, as far as installation, on my Android phone, if I want to install software that's not in the store, they have one of those funny-looking square things that you scan with a barcode reader, and it just gets installed.
Yeah. But Android is too, like, if we want to do something, we can't use Android for the moment because of the audio. But we could do something for the iPad because the audio is a bit better.
PD running my Android is perfect. So
Yeah, but then,
PD is better.
It's the latency.
No.
It's the latency problem.
You can't get latency. You know, you can't get low
I've got
latency.
real-time audio input and output. It's not that bad at all. I would say it's as good as whatever I get in an iPhone. You can have a concert.
Show us later.
Yeah.
We want to see this.
Yeah.
Want to see it?
No problem.
But whether now or later, it's got to run on a gadget like this.
Yeah.
It's got to run.
And I don't know all the advantages, I agree, it's just nice to control
The
them.
advantage
but-
is that everybody has these
Thank
things.
you, I think, I don't know, I just think, it's,
It's what people
I think
have.
the advantages will come to us as we have it floating around and you could distribute versions that way. I don't know, and maybe it is a potential source for some revenue.
The main advantage is it's fun. You know,
Yeah, well, there you go.
Making it fun and attract people to use it more.
This thing is small. Is really as small as a lot of pads, although it's heavier. And it makes a huge difference to have this instead of a larger computer. A huge difference. I have this with me all the time. If I had a pad, like a 7-inch pad or something, I wouldn't have to have a backpack, and I'd still have it with me all the time.
Okay, thank you very much. I think we'll conclude this session and this concert at 7:30. Please come along to it.
You mean 5 minutes break, or what do you mean? Or
We'll just conclude the session. We conclude the session because we covered all the aspects.
Okay.
Unless the audience have things.
Unless the audience would like to say something. If you choose.
I thought Andrés had a contribution. Am I wrong?
No, because we
throw out some thoughts.
Yeah, you can do. Certainly.
I just have sort of it's a very ambitious title, just me saying towards csound 6. Just wanted to throw out a few ideas. I think we were just discussing now something that could be framed as with a question of what's the purpose, what's the vision, what's the goal of csound, what's the design philosophy, what are we looking for, what are we offering. I think it's good to ask that question as it helps us know where we're going and let us think if we're going in the right direction. And it's also a bit of a balance between what we think csound should be, or people think csound should be, and individual developer motivation, because I guess that's why we all do it. Because it's fun, sort of these projects that we can use for ourselves. But that common source of purpose is also really important. Some ideas for helping csound grow, which I think might work, is using a system like the PP system for Python, which sort of gathers together proposals and they get discussed. A bit like what I've tried to start up in the wiki, where I write up stuff and see and let people read and comment on them, especially for the larger features of the language, so that they get discussed and so the best solution can be found after that discussion. Another idea which has come into my mind is there's a big history of csound programs, but it would be nice if there was more encouragement of reusability and encapsulation. This has always been a problem of most music languages, but I think it's something that's worth exploring. How can we make this easier for users to reuse existing code? Because in practice it tends to be still a lot of work. Should it be some kind of sharing website, or better integrations in things, or maybe a command line utility that can work with the code? I don't know. Some thoughts.
You mean
and
something
I was thinking also for some things that could be done, sort of thinking beyond parallel csound, which is sort of the big milestone we'll get to. One thing that would be nice to have is real-time safe memory allocation. Have a big memory pool, which opcodes can draw from, rather than doing the current allocation they do, which is non-real-time safe. It's probably not bad in most cases, but it can cause glitches. Also think about maybe performance and optimization improvements, like compiler optimizations or vectorizing, or using something like the Nova Synth library that the supercompiler is using for speeding up DSP processing. And I also had two more ideas related to code introspection and debugging. Maybe allowing csound to be run like through a debugger step by step, or maybe being able to set breakpoints to see how the data is at that particular time in a run of the csound orchestra, or be able to traverse maybe the flow graph node by node to see how it's running, if it's doing what you expect. And eventually also weed out the csound garden, which tends to be a bit overgrown in certain parts. One that I found recently is the headers for the opcodes, for the opcode libraries. When you're developing an opcode, you say, oh yes, I include a single header. But if you look at that header, it includes another 2, which then include another 4. So it's really a big mess. So if you want to make an SDK for building csound plugins, it's actually quite a big thing. When I think it shouldn't be. It should be simpler.
However, let me just say this about this. It's not like I speak for OS10 because that's what I release and package. It's not a big thing to build an opcode. It's just one single command line. You build an opcode, and if you're in Xcode, It's just a matter of finding where the framework, where the headers for your framework is. So you just dragging your framework there. There's no need to link. There's no need to link to lib sound file, which was there before. There's no need to get the sound file headers as well, which was there before. So it's simpler than it was, and because we, in the case of the US standard, you have all the headers installed there. It's no big deal. It might, for other systems, I don't know, it might be a problem. But like for instance for US 10, it's not really a deal. But I mean, code refactoring is something that you really need to. Is something that it's important to consider for csound 6.
Yeah, absolutely. I'm also thinking more of the case, not so much of building, because as you say, that's fairly easy, but more of writing tools to interact with dynamic libraries, sort of to extract the available plugins installed in the system, which you currently have to load csound to do that, because it's very, very tricky to write a post for plugins. I tried that sort of just to query what plugins were available, and the only way to do it is to run csound. But it might be interesting to simplify those APIs to allow these kind of things, which give more flexibility to the system. But it's like you say, just a question of refactoring, because it's become a bit entangled through sort of its very organic growth of the years. And finally, I guess the csound API needs a bit of a cleanup, like we talked today. Another thing that comes to mind is there's a messaging system, well, not a messaging system, but rather a message buffer that stores the messages from csound. But it's actually not very usable in practice by front ends because I can't remember the reason, but it's not very practical to use. So thinking of removing things like that, consolidating the software buses into a single API system rather than the 3 or 4 that we currently have, and well, that kind of cleanup, I think it's very important to get towards on 6 as well. So I'd like to hear your thoughts. What else do you think is needed for csound 6? Where should we go?
Well, Michael had a long list which we discussed before.
Mm-hmm.
But I think a lot of things you said make sense. I think the main one important goal that we have to keep, I think, is to going forward, but also keep the backwards compatibility. So this has to be considered clearly. When we consolidate, for instance, the channels into a single one, effectively what we have to do is just keep the same interface there. Maybe we'll have a single way of dealing with them, but you can't break orchestras and scores that were there before using them.
I have something to say about your point on reusability and encapsulation. In the LaTeX world, there's this thing called ctan. It's a repository online for all of the packages that a LaTeX system can use. So you can just include by name the library you want, and then when you run LaTeX, it will go online and go to the repository and download the code and install it and run it. It's completely transparent. The only reason you know this is happening is because you see some extra messages while your LaTeX session is running. And I think could easily be made to do that. If we had, user-defined opcodes and sound file samples and stuff like that in a repository, it would be, this would not be using it from that place. It would download it onto your computer and then use it. But this works extremely well in LaTeX, and I think we could do something like that. The other thing is, I think your idea about a PYPE system for csound is a very good idea.
Yeah.
There was one thing I was thinking related to what Victor said. It escaped my mind. Trying to think later.
Is that about backwards compatibility? No.
No, I'll remember it a little while and I'll try to bring it back.
Can we just be sure, is backward compatibility absolutely given?
I think it must be given for the score and the orchestra. I don't care about the command line, the utilities, the documentation, anything.
I'm talking about pieces, not how you attack pieces.
Pieces.
Yeah.
That's what I mean.
Yeah,
If you can render a piece, even if you have to change the command to render the piece, if you can get the piece to render, that's fine, and we must preserve that. It's been so valuable musically. All I care about in the end is the music. Musically, it's been wonderful that I can get pieces that are old to run and hear Risset's catalog stuff, or all these people that don't even do anything anymore that I know about, like James Deschaux and people like that. If I can hear this stuff, I can use their instruments, I can see their ideas. It's fantastic.
I'm just asking the question I'd like to have it explicit, because I actually think backward compatibility is not negotiable.
No, I don't think I agree.
That's what I'm saying.
Yeah,
I don't think it's negotiable.
I just want to make sure. I want to make it explicit.
Yes, I think it should be.
Some people suggest
if there's no backward compatibility, it's not csound anymore.
Right.
It's something else. Yeah. If you're interested in that, you can get your code and fork it and get your community and do it.
And people have tried to do that, and they have produced working ports of csound, some of which had notable advantages, and yet they're not being used.
Yeah. In the end,
Sorry, I was thinking about the duplicate APIs. What could be done maybe eventually is deprecate some of them, move them to the end of the API, and sort of try to promote usage of a single API for that kind of purpose, and eventually in csound 10 we'll get rid of them or something.
But you're talking about the opcodes.
No, I'm talking about opcodes.
The API, API it doesn't need to be. This is a bit backward compatibility. The API is not what you're talking about.
There's a different way of doing the API, which was the one Richard Dobson was advocating years ago, which essentially means that you get the function by passing a name for what you want.
We actually, there's still a little fragment of that code in the csound API that nobody ever uses, and it was my intention that it be done that way, and that's just not how it worked out.
That was Richard's intention. He was very annoyed about it, actually. It should be done that way, because that way you don't have.
It was modeled on COM, which was very well designed in this regard.
That's why
it had a query interface and addref release.
If you're changing version, if you're moving to csound 6, I don't see that we need to maintain API compatibility, because
but what you're talking about is excellent, because COM and Dobson's idea both had built into them the query interface idea.
Yeah, that's right, yeah.
So when you ask for an interface that's not supported on your system, it will tell you. And if you ask for a generic unversioned interface and you're expecting an old one, it'll give you the new one. Yeah. And this is what we want.
Yeah, exactly.
Yeah, but we have to make sure that we don't make it too complicated.
It actually makes the code a lot easier.
It's not that complicated.
Yeah.
We don't have to do everything that COM does. We don't have to have a repository. We don't have to have anything like that. We just need to, somebody gives us a name,
and also
we give
something
them
that
a
can,
pointer.
we want something that can translate well into other languages, which is something we've been talking about. There's no point on. That's how these things have to be.
We do that, but basically in the other languages, just when you ask for
they all end up
it gives you one of their
calling
functions.
Yeah, right.
It's all doable. It does actually make life a bit easier, I think.
Yeah, I mean, my opinion is that I don't know what you think, but if we move on to csound 6, the reason for moving on to csound 6, not to tag another version to csound 5, is to be able to do all these things without saying, oh, my front end doesn't work anymore.
Right.
Let's look at that one more seriously.
And one more thing to close is thinking about this personality of csound and what makes it special. I think one thing that's usually underestimated is the csound syntax. It's very archaic. Yes. Well, I'm thinking about particularly of the orchestra syntax. It's very archaic, but actually it's very, very simple. so it's perfect for non-musicians. When you see musicians try to learn Super Collider, you really pity them because it's something that's not designed for non-musicians. Has so many computer science concepts in it. That actually, I think the syntax csound is actually one of its strong points in a way.
I agree, and I can tell you from experience that that is true. You know, my students learn csound, and they're musicians who played with synthesizers. And to learn csound and think like it's a modular synthesizer has been its great strength. Now that you've added UDOs and loops and instruments calling other instruments, it pushes them to think a little more like a programmer and think a little more like an instrument, like a function. It's wonderful the way it's evolving, but they can start by learning the basics. We'll talk more about this tomorrow, but I'm always glad when I hear developers not think we need to turn it into Super Collider, because I can't teach Super Collider, I'm sure of that. I would be stopping teaching the hundreds of students I teach every year that learn csound, and it changes them because they come into this world where they can grow instead of being kind of thrown out because they just didn't have the underlying computer science concepts that would help them understand a way of thinking about sound in that way. I'm convinced of it.
When I started, actually, one of the things I thought of, I was I'm a mathematician, computer scientist. I thought, well, we convert this into a real programming language. And it took me about 10 minutes, I think, with Rick, to convince me that was just not the right thing to do. One of the things I think we can do is there are people who like more not functional programming, but the more functional attitude to opcodes. And I've talked to Victor about this, and I can almost see how to do that as an optional in the new parser. So you can do it one way, or you can do it either way. There's a technical problem where I just can't switch it on. If people want that, either as a slightly different parser or the same thing, that's okay. But I'm certainly the idea of having functions and locally declared variables and all that sort of block structuring and things. I gave that up about 20 odd years ago now.
Right. I'm glad you did.
You see, the way we're looking at this is that this thing might be possible if someone comes along and wants to develop an alternative language with all these things that will compile, these flow graphs, that what we want for running the synthesizer. That will, we want to enable that possibility of someone to come in doing that. But alongside as an alternative to, the traditional csound language.
Yeah. I think the new parser does actually allow the option, with a bit of work, of allowing people to have their own version of the language if that's what they really want.
And, there's two sides to this. If we separate the runtime from the compiler, you can do two things. You can keep the old runtime and use a new compiler, or you can keep the old compiler and use a new runtime.
Precisely.
Pluggable components.
What?
Pluggable components. You were talking about.
That's right. That's exactly what I'm talking about.
Yeah. Okay. And would you like to add anything else, Andrés?
Well, just a little thing that came to my mind recently. There's the Novel forum, which archives the csound mailing list, but I think it's connected to the BATH csound mailing list. I think it might be worthwhile to set up a new Novel forum for the new list, or just be sure to point people to the SourceForge web interface for that, as there have been interesting questions and people coming in to see some from the Novel forum, which wouldn't have come otherwise. So keep those avenues open.
Well, this is not dead yet.
Sorry, I was going to talk about this under the more developed thing. There is a possibility of having to change the list, and there's a shadow list running at the moment with the same people on it. And I've already been thinking about one of the things we need to worry about is, do we need to transfer, and if so, when? I don't think that's really a developer issue, that's a user issue. But yes, I agree, the Navel people have done quite a lot in bringing people in, even if they don't realise it's not their mailing list. I'm in communication with them occasionally. We've talked about security between them and spam and stuff. So.
Okay. So thank you very much. And would you like to say a little bit about the next steps in the conference?
Well, there is the concert this evening, as you know. It's not here, it's in the Kammermusiksaal Platnerstraße, 10 minutes walk, starting at 7:30. So, if you like, I think I depart at 7, you can come with me, but you will find the way with the maps. And we continue tomorrow at 9 with the next paper session. Well, yes. I think that's
it. Thank you very much.
Thank you for sharing, Victor.
Thank you very much. Sorry for the delay.